Now, before we start, see the quote, push yourself because no one else is going to do it for you. So guys, if you keep waiting for somebody else to arrive and help you out from any situation, that is not at all going to happen. What you need to do, you need to become able to come out of situation, to come out of difficulties, to continuously move forward. You need to push yourself forward because otherwise nobody else can do that for you. Are you getting my point? You need to do that. So you need to keep moving, you need to move ahead. And you need to keep giving your best no matter how many odds are stacked against you. Even if all the odds are against you, you need to do well in your life so that you can come out on the top, guys. Because once you are not able to do well, none of the excuses will work out in your life. And stop giving excuses to yourself, your family, your colleagues. You yourself are responsible for your success and failure, because there is abundance of resources. There is abundance of resources all around. What you need to do is you need to make the best use of those resources and you need to come out on the top. No matter whatever you do in life, make sure that you are doing it to the best of your ability and you are coming out on the top. Okay. So with that thing in mind, let's get started. Yeah, let's get started and let's learn something new. So what is the topic for today? The topic for today is the number system. So we are going to discuss about number system. We are going to discuss what are the different number systems and how can we convert a number between such systems. So let's get started. So what are the different type of system? Number systems, then BCD, then data representation. These all things are the syllabus of this chapter. So what I have written here is base n. Then we have octal, hexadecimal, binary and decimal. Octal means the base is 8. Hexadecimal means the base is 16. Binary means the base is 2. And decimal means the base is 10. Base is 10. Okay, please start the class from 4:30 because from 5:30 Reddy sir class is there on Unacademy. See guys, why I can't start on 4:30? Actually, my wife also teaches on Unacademy. She has a class from 4 to 5 and she is using the studio. Maybe in the long run, I might switch the time when I have 2 studios, but right now I only have 1 studio. So we have to adjust the times accordingly. She takes it from 4 to 5, then I take it from 5 to 6, then she takes it from 6 to 7, then I take it from 7 to 8, and then she takes at 8, and again I take back at 9:30. So that way we manage throughout one studio because students are only free in the evening. So we have to make the best use of the evening. Okay. So pardon me for that, but I can't help it. Then there is a BCD. What is this BCD, sir? This BCD, guys, it means, I think it is not visible as such. It means binary coded decimal. I'll tell you everything about these in detail. Don't worry. Everything we are going to cover in detail. No need to worry about anything. Then data representation, n minus 1's complement and n's complement, you can say n's complement. Okay, n minus 1's complement and n's complement. So these are the two way of representing any data system. Like in binary, we will have 1's complement and we will have 2's complement. Okay. So these are the different topics that we are going to study, as well as I am going to tell you about the floating point and the fixed point arithmetic that is specifically there in computer science, not in other branches. So guys, after watching this number systems videos, whatever lectures we are going to cover, one thing is for sure, you will be able to solve all the questions that have been asked in the previous year. You will be able to solve everything. Okay. Now, let's get started. Number system of different base. So when we talk about number system, we talk about a positional number system. Now, sir, what is a positional number system? The positional number system is a system in which the position of the digit determines the weightage attributed to that digit. That is, how much important that digit is depends on the placement. Now, let us see an example. Suppose I write a number 619. Okay. Many of you might remember Rey Mysterio by that number 619. Now 6 we call it in the hundreds place, 1 is in the tens place and 9 is in the units place. That means the weightage of 6 is 100, the weightage of 1 is 10 and the weightage of 9 is 1. So that way we have constructed the number 619. Such kind of numbers are called as the positional number system. Okay. So it is the positional number system. The radix or base is the number of unique digits. Okay, unique digits including the digit 0. Now what does this mean? Suppose I take a base of 2, then that means there are 2 digits in that number system. If I take a base of 10, then that means there are 10 digits in that number system. If I take a base of 16, that means there are 16 digits in that number. Sorry, 16 digits in that system. So in binary, there are 2 digits 0 and 1. In ternary, there are 3 digits 0, 1 and 2. In octal, 0 to 7. Decimal, 0 to 9. What about hexadecimal? 0 to 9 and A to F. So now A here will represent 10. B will represent 11. C will represent 12. D will be 13. E will be 14. And F will be 15. Now sir, why did you write it as alphabet instead of number? Because my dear, when I write 14, somebody might read it as 1 and 4. Okay, 1 and 4. But I want it to be read as 14. That is why I have written it as E. So remember this. That is why in decimal there are only 10 digits, because when you write 10, it becomes 1 and 0. 1 and 0. Okay. So that is why we have included 6 alphabets. So 10 numbers, then 6 alphabet. Is that clear? Up to here it is clear. So what is the base? Base is the number of digits that are being used in a particular number system. Like in decimal, 10 digits are there. In hexadecimal, 16 digits are there. So are you able to understand what is the meaning of base? Everybody clear? Everybody clear or not? Come on, quickly tell me in the chat. I am able to read your chat. I have opened it in the front of monitor. Tell me. Okay. और बेसिक से चल रहा है ना भाई सब लोग? बेसिक से समझ आ रहा है? We are going from the very basic. Nothing is fast. Nothing is fast. Tell me, nothing is fast. You are able to understand from the very basic? Tell me, guys. Okay. Rahul is saying in computer, why everything is in the power of 2. Rahul, see, in computer we use the binary number system. Why do we use binary number system? Because everything can have 2 states, that is high and low. If you have more number of states, then it is we are unable to identify, because as the number of states increase, the difference between them will go on decreasing. That means suppose from 0 to 5 volt, if you define 10 states, every state will be differing by 0.5 volt. But if there are only 2 states, they are differing by 5 volt. Okay. So we want very clear difference between the 2 states. High means high, low means low. If they are very close to each other, we might not be able to differentiate between high and low. That is the main reason why we talk about binary, that is 0 and 1. Okay. Now, let's move forward, dear friends. Now we need to understand about conversion of base. What about how to convert from one base to the other? See, these base values or the number system, they are different ways of representing the same number. They are different ways of representing the same number. That is, if I write a number 619, it can be present in decimal, binary, octal, hexadecimal, everywhere. You can write one single number in multiple ways. But what I need to understand is how to go from one base to the other, or how to go from one number system to the other. That is what we need to understand. Okay. So the first and the most basic conversion that you need to understand is from decimal to any other base. Now decimal, suppose I write a number 619, that is in decimal, that is on a base of 10. Now suppose I want to take it to a base of 2. What we need to do? We need to continuously divide it by 2 and every time note down the remainder. Understand again, जो भी नंबर आपके पास है, सपोज 619, इसे बार बार 2 से डिवाइड करते जाएंगे और रिमाइंडर्स को अलग से नोट करते जाएंगे. Completely divide a number again and again by 2 and every time note down the remainders. So these steps are written. Divide the decimal number by the value of new base. Get the remainder as the rightmost digit. Okay. Divide the quotient again by the new base. Again get the remainder and do it continuously till the quotient or the remainder, till the quotient becomes 1. Let me tell it by an example. I know it is difficult to understand right now. Let me tell it by an example. Suppose I take this example. 619 is a very beautiful number, but it is a big number. Chalo. Let me convert it to a base of 8. I want to convert it to a base of 8. Now what to do? 619 by 8. This is quotient, this is remainder. Tell me the quotient. 8, 7, 56, 59. 8, 7, 56. Remainder is 3. Okay, 8, 7, 56, 56. Now divide the quotient again by 8. 8, 9, 72, 5. Divide 9 by 8. 1, 1. Now this quotient is 1. So that means if you divide 1 by 8, you will get 0 and 1. Now when you are expressing the number, then what you do? You go in the reverse order. That is 1, 1, 5, 3, 8. Understood everyone? Is this understood or not? What we need to do? We need to divide it by new base. We need to note down the quotient and remainder. We need to divide the quotient again by the new base and do this until we get the quotient as 0 or we say remainder is 1. So then we write down these numbers in the opposite order. Clear or not? Tell me, clear or not? Okay, great. This is right, hai na? 864, yeah. Chalo. Now what about if I want to come back? So while going from decimal to other number system, we were continuously dividing. Now we will multiply to come back to the original number system or to come back to the decimal number system. Now initially I told that it is a positional number system, right? I told like 619 can be written as 6 into 100 plus 1 into 10 plus 9 into 1. Or listen carefully, 6 into 100, 1 into 10, 9 into 1. Or 6 into 10 की power 2 plus 1 into 10 to the power 1 plus 9 into 10 to the power 0. That means we are multiplying it by the powers of 10 based on the position of a digit. Correct? Everybody agrees with me? We are multiplying the number with the powers of 10 based on their position. Can you tell me, is it right or wrong? Can you tell me? No. Rahul, remainder can never be greater than 8, right? Whenever we divide a number by another number, the remainder cannot be by the, cannot be greater than the number in denominator. Okay. See, determine the positional value of each digit that depends on the position and base of the number system. Multiply it by the digits and then you add the products. Sir, we did not understand. Kindly explain again. Okay. मुझे ही नहीं समझ आया, तुम्हें कैसे आएगा? एग्जाम्पल से समझते हैं यार, ये सारी चीजें एग्जाम्पल वाली हैं. सपोज आई टेक द नंबर बैक 1153. नाउ आई मस्ट गेट द सेम नंबर बैक in decimal, correct? So, what do we write? We will write 8 to the power 0, 8 to the power 1. Okay. Based on their position, they will be multiplied by increasing powers of 8. So, what we will say? 1 into 8 to the power 3, 1 into 8 to the power 2, 5 into 8 plus 3 into 8 to the power 0. 512. 580, 578, 618. Just a minute. Right, 1153. Okay. 512 plus 64 plus 40 plus 3. So 578. What is the mistake? Why am I not able to get the same number? 24 plus 40, 64. Sorry, 3 plus 40, 43 plus 64. 6 और 3, 9. अरे 76 है ना, मैं क्या कर रहा हूँ, आ तो गया. Sometimes what happens when I calculate verbally, I make a mistake. But I was making a mistake na. 512 plus 64 will be 576. I was taking it as 518. Sorry, 578. That was a mistake I was committing. Okay. So it is coming out as 619. So are you getting my point? When we come back to decimal, then we multiply the number or the digits of the number with powers of base based on their position. With powers of base based on their position. But when we go from decimal to the other base, then we successively divide by the base, collect the remainder, then we write it in the reverse direction. Reverse direction. Yes, yes, yes. हेमंत बेटा सिली मिस्टेक कर देने से कोई पढ़ाना थोड़ी छोड़ देंगे, सोचने वाली बात है. And just to tell you all, I am very good in verbal calculations. Just sometimes verbal calculation will be a drawback. Sometimes we'll commit errors in them. Okay. So, but verbal calculation is very, very necessary when you talk about GATE exam, because not every time we can make use of virtual calculator. Now, okay. So, other base system to non-decimal, that is, suppose I want to go from binary to ternary, let us say, or ternary to binary. I don't want to end up in decimal, neither I am going from decimal nor I am going to decimal. Okay, neither I am going from decimal nor I am going to decimal. Okay, then what we need to do? Then we need to do it in 2 steps. Suppose I am going from binary to ternary. Then first I'll go from binary to decimal, then decimal to ternary. Simple solution, correct? It's a very simple solution. Binary to decimal, then decimal to ternary. We'll simply move from one number system to the other number system. Now see, let's take an example. Right? Okay, let me take binary to ternary. Now, first of all, I need to convert binary to decimal. Okay. So, I will multiply it with powers of 2 depending upon their position. Correct? So it will be 1 into 2 to the power 3 plus 0 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0. 8 and 1, 9. Now what you need to do? You need to go from decimal to ternary. You will go from decimal to ternary. So what will you do here? 9 by 3, 3, 0. 3 by 3, 1, 0. Then 1 by 3, 0, 1. So how will I write it in on a base of 3? I'll write in the reverse order 1, 0, 0 on a base of 3. Is it understood? Is it understood? Prasad, there is a shortcut whenever the other base is also in power of 2. Suppose there is a base 8, octal. Then binary to octal or octal to binary, there is a shortcut. But otherwise, there are no such shortcut when we can go from one number system to the other. When you are going from random number system, then you have to follow the whole process. But if you are going from a number system of 2 to a number system which is a multiple, or you can say power of 2. Suppose we are going from 2 to 8, 2 to 16, all are power of 2. Then there are direct techniques. Okay. Then there are direct techniques. We'll come to them as well. Okay. Now understood? Okay. Now, we talk about binary to octal. See, octal has a base of 8. Binary has a base of 2. So, what we can say? 8 is actually 2 to the power 3. 2 to the power 3. So, now when we are going from binary to octal, what we need to do? GATE PYQ, I'll solve it for you. Don't worry guys. We'll solve all the previous year question either here or in special classes, but we'll do. Some questions we'll see in the class. Some I'll solve for you in the special classes. But you don't need to do much on your end. You just need to attend these classes and I'll help you do everything. Okay. Now, 8 is equal to 2 to the power 3. So, what we will do is, we will divide the binary digit into groups of 3. Into groups of 3 starting from the right. Starting from the right. Now, every 3 binary digit will become an octal digit. And let me tell you one more interesting fact. When we say about binary digit, the short form of binary digit is bit. Bit is nothing but the short form of binary digit. So, when we combine 3 binary digits, we will get one octal digit. Now, what are the representation of each octal number in binary? So, 0, 0, 0 means 0. 0, 0, 1 means 1. 0, 1, 0 means 2. 0, 1, 1 means 3. 1, 0, 0 means 4. 1, 0, 1 means 5. 1, 1, 0 means 6. Okay, that way. So, whenever you group the bits in the group of 3, every time you will replace the 3 bits by a corresponding octal digit. Now, sir, how did you derive? How can you write this? See, how can I write this? Simply based on decimal to binary. Decimal to binary, let me take an example. Suppose 7. I need to convert. Suppose 7 is there. I need to convert it to 2. So, 7 by 2, 3, 1. 3 by 2, 1, 1. 1 by 2, 0, 1. See, 1, 1, 1. Like this. Like this, we have obtained everything, every number in binary. Like this, we have obtained every number in binary. I know, Sanjeev, the screen is blinking. Actually, this is Unacademy studio. There is some technical glitch. I had come to the office for a certain meeting, but generally the tasks when I come to office are so many that I have to stick here. So I could not take this class from my own studio. That is why I have to take it from Unacademy. Okay. Now listen. So what you need to understand, you need to remember this. How to remember this, sir? How to remember this? Write it here like, see, 0, 0, 0. Then change the last digit. Then okay. See, it goes like 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1. 4 zeros, 4 ones. If there was other digit, it will be 8 zeros, then 8 ones. Are you getting my point? 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1. 4 zeros, 4 ones, 4 zeros, 4 ones. Like this. Are you getting my point? How to write this? If you can't remember, this is very basic. This is how we teach the students of class 11th and 12th about digital, that how do we write different binary digit. Now let us see an example, binary to octal. Okay. Let us say, let us see. Suppose I want to know what it is on a base of 8. Would you guys like to try it once? Would you guys like to try it once before I solve this? Can you try? Come on everyone, try it. I want to see how my students do it. Let me see it. Come on. Chalo, try it. I need answer on a base of 8. Subhash is telling me 1, 4, 5. What about others? Come on everybody. Come on, come on, come on. Number system is feeling easy, right? Difficulty is about to increase in the coming classes. क्या होता है बेटा, किसी भी बकरे को हलाल करने से पहले ना उसे खिलाया पिलाया जाता है, मोटा किया जाता है. सेम वे राइट नाउ आई एम फीडिंग यू. लेटर ऑन यू विल सी हाउ ब्रूटल दिस चैप्टर इज. ओके ओके, डोंट वरी, वी आर टुगेदर. आई विल हेल्प यू. सी, start forming groups of 3 from the right. 3, 3. Sir, now this one is left alone. It is feeling bad. So give it 2 zeros. Okay. Now 3, 3, 3. You know na, we can add as many zeros as we want at the beginning of number. The zeros at the beginning do not matter, but what matters is the zeros after the number, right? If I write 1, it does not have much value. If I write 1, 0, it has 10 times the value. But 0, 1 has the same value as 1. Correct? Correct? आपके हाथ में 1 रुपया दे दिया जाए, उसे 1 रुपये लिखो या 0, 1 लिखो, बात तो बराबर ही है. लेकिन 1, 0 लिख दिया तो 10 हो गया. समझ गए? चलो. Now see, 1, 0, 1 is 5. 1, 0, 0, 4. 0, 0, 1, 1. If you can't solve this, write like this. 2 to the power 0, 2 to the power 1, 2 to the power 2. 2 to the power 0, 2 to the power 1, 2 to the power 2. Now see, now easy. 4, 1, 5, 4 and only 1. See the power of 2 at the digits which are 1, which are not 0. Now 1, 4, 5, you can write it. Shall we see one more example? Shall we see one more example? Okay, let us see. Let us see. Now try. Even I don't know how I have written this number. I have just written it. Now try. I want to see how many people can solve this. I want it on a base of 8. Okay. अब मजा आ रहा है little bit in Hindi. Okay, we'll mix it. And nobody from the south should be worried. Every concept will be taught in English. Okay. Actually, I don't know other languages. Otherwise, I could have told you some things in Telugu, Kannada. Sravant has already answered 221631, looking like a mobile number. Arey baba re. Chalo, let us see. Let us see if your eyesight is working well. Okay. Sometimes my eyesight might also be weak. Okay. Actually, my eyesight is weak, though I don't wear specs. Now I'll arrange one more 0, 2, 2, 1, 6, 3, 2, 1. Arey wah. The answer is this. 2216321. 2216321. Very good. Very good. Now you have understood how to go from binary to octal. Very easy part. Now, let's come to the next step, octal to binary. This is even easier than that. Here, every digit of octal, you will write it in terms of 3 binary digits. You will write it in terms of 3 binary digits. Suppose 7 is written, replace it by 111. Suppose 6 is written, 110. Suppose 5 is written, 101. As simple as that. Just replace each digit of octal number by binary digits. See, let us take an example. Okay. Now, suppose I want to write it in binary. 2 is 010, 4 is 100, 6 is 110, 7 111, 5 101, 3 011 and 1. See how simple. Replace each digit by binary number. Replace each digit by binary number. Understood, everybody? This is the shortcut that some of you were asking about. Now let me see. Now convert it to binary. Convert it to binary. Sanjeev, I'll share the PDF, my dear friend. I'll share the PDF here. Just a minute. Join my Telegram channel. This is my Telegram channel. I'll share the PDF here. Okay. And for any doubts and discussion, this is the group. Okay. I know, guys, screen is flickering. Actually, I'm in the studio. I can't do much about it. I'm not at my home. I came to office, but I didn't want to miss this class. That is why I'm taking from here. Siva, actually, it will be better if RBR sir makes it because he knows all the subject. I know only a few. And after this digital is completed, I'll try and take maths as well for you. Okay? Would you guys like it? आप लोगों को अच्छा लगेगा भाई अगर मैथ्स भी लेके आते हैं इसके बाद? बताओ. Anybody able to solve this? Tell me. Even if you have written the answer in your copy, just write it down and tell me done. If you tell me done, I'll write the correct answer. Okay. Yash has already given me an answer. Let me solve. See, digital is just a game of zeros and ones. One of the easiest subject of all times. But if you get confused or your eyesight is weak, it can be very, very dangerous. See how easy it was? Convert every digit to binary. Convert every digit to binary. Done. As simple as that. Now, similarly, we can go from binary to hexadecimal. The base of hexadecimal is 16, which is 2 to the power 4. See, 2 to the power 4. So, what we need to do here? We need to take 4 digits of binary and convert it to hexadecimal. Okay, see how? 0, 0, 0, 0 will be 0. Here we need to represent in 4 digits. It is 1, okay. Again use the same method I told na. Last one is 0, 1, 0, 1, 0, 1, 0, 1. Then the second last 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. Third last 4 zeros, 4 ones, 4 zeros, 4 ones. And the most significant, this is the most significant bit, that is having the highest weightage or the highest priority. It will be 8 zeros and 8 ones. Okay. If anybody has even any the tiniest doubt, even the basic doubt, you guys can ask me. Don't worry. And guys, soon enough, Ravindra sir is also planning some subjects for YouTube family. Why do I call it family? Because you are just like our students that are sitting in front of us. And daily when we are teaching you guys, we get a family type of a feeling. We get a family type of a feeling. That is why I call it as family, YouTube family. Pushkar, I'll try to take it myself and try to take the complete mathematics as well. Don't worry. But first of all, let us complete digital completely. Combinational, sequential, number system, K-map, everything. Everything we will try to cover completely, and then we will move on to the next subject. Actually, RBR sir wanted that we start from digital. He said computer science students love this more than the maths. Arnab Reddy sir will be teaching on Unacademy platform and he'll take free classes on Unacademy special classes. Okay. That is why you need to have Unacademy app even if you don't purchase the subscription, but do have Unacademy app in your phone. Okay. Chalo. Let us take an example, right? Right. Let me write down a number. Now try this. I want it to be converted to hexadecimal. And here 1 minute, guys. Just let me change. Actually, from 10, we don't need numbers, right? From 10 onwards, what do? We write alphabets. Correct? Okay. Now try this. No, Sravanti, actually memory is not there in computer science. So I don't think I'll be covering here. You guys don't need memory, right? SRAM, DRAM, all those things. SRAM is still easy, but DRAM requires the use of capacitor, transistor. So I don't think CSE student will be able to understand it at that level. Otherwise, I'll have to give you a lot of background here. So that will be covered in COA, na? Why are you worried? Yes, I'll cover all DLD topics. Don't worry. We'll go from the very basic, yaar. Right now it is February. Why are you worried about the completion? I have told you I'll take around 40 to 45 hours and I'll complete the syllabus. Okay, don't be worried, yaar. It doesn't look good. When I have committed something to you, I'll complete it. Okay. Now 3 digits are remaining. I'll add a 0. I'll make it 4. 8 and 4, 12. 12 means 10, 11, 12. C. 2, 1. 8 and 2, 10 and 1, 11. B. 8. Right? No, not 8, 4. This is 4. 4, B, 1, 2, C. Correct? Is this clear? Is this clear? Okay, many people have gotten the correct answer. Very good, everyone. Very good. Now, hexadecimal to binary, simply go the other way. That is, represent every hexadecimal digit in a group of 4 binary digit. अर्नब पॉइंट वाला कंसेप्ट मैं कल कराऊंगा बेटा. डेसिमल वाला ना पॉइंट हम लोग कल कवर करेंगे. हाउ टू डील विद डेसिमल. डोंट वरी, आपका एक भी कॉर्नर नहीं छोड़ेंगे यार. देखो, फर्स्ट ऑफ ऑल लेट मी टेल यू वन थिंग अबाउट माई सेल्फ यार. whenever I am teaching, I am not teaching thinking कि प्लस वाले को ये देना चाहिए और यूट्यूब वाले को इतना देना चाहिए. I don't think like that. What to give to the plus student and what to give to the YouTube. Whenever I teach in full form. I teach everything from the very basic to the very advanced level. I'll teach you each and every corner. Okay. I might not take it on plus. I might take it on plus. That doesn't matter. But whenever I am teaching, I am in the teaching mode. I am giving you everything. Godu, basically it is a way of conversion. It is not why we are grouping or why we are doing it like this. We just have said that 2 to the power 16 is 2 to the power 4. So when we group 4 digits of binary, we get one hexadecimal digit. Now hexadecimal to binary means we will write each hexadecimal digit in a group of 4 binary. Suppose 4, B, C, D, A, 9, 7, 5. Convert it to binary, yaar. Convert it to binary. Yes, 0 to hero level. So don't worry, your complete digital will be covered here. I love teaching, and right now I am taking like 2 to 3 classes daily on YouTube only. Different channel. मिलिंद, अभी बेटा मैंने स्पेशल कोई नहीं बनाई है CS वाले बच्चों के लिए. अच्छा, यू टेल मी व्हाट यू वांट फ्रॉम माय साइड इन स्पेशल. शुड वी स्टार्ट प्रोबेबिलिटी इन स्पेशल? Should we start probability in special? Would you like it? Kiran, I am thinking about everybody, yaar. Arey, I can't teach COA, bhai. I am from electrical. I can't teach for computer science core subject. For that, I'll also have to study. Acha, chalo, I'll create a special class on probability very soon, and then we'll discuss probability as well. Okay. Now try this, guys. Why are you taking time? Convert everything to binary. 9, 10, 11. 11 means C, 12. D, 13. Okay. A, 10. 9, 7, 5. Okay. So this will be the answer in binary. Aptitude Saurabh sir is taking aptitude Saurabh sir is taking in a great manner. Okay. Aptitude Saurabh sir is taking, don't worry about it. Is this clear? Chalo. Now see this question. 2.3 on a base of 4 plus 1.2 on a base of 4 is equal to y on a base of 4. Y on a base of 4. Sanjeev, Saurabh sir is taking on YouTube only, na? He has a channel called Apr Express, as well as he took some sessions on this YouTube channel also. Don't worry about point, Arnab. I'll tell you how to deal with this question. Just try it once. I'll tell you about from normal addition. Kapil is saying A. Okay. We will see. Arnab is saying A. See, the time is up. So let me show. 2.3. Now you will say, sir, 3 and 2 will be 5. But when we have a base of 4, the only digits that are possible is 0, 1, 2, 3. So when you convert 5 to a base of 4, 1, 1. So it is. Okay. So I will write it as 1 and I will carry 1 here. 1 plus 2 plus 1, that is 4. But digits are only allowed up to 3. So what will 4 become? This is quotient, this is remainder. So 4 will become 1, 0. So answer is A. Understood how I did it? Like the basic you used to do for decimal, whenever you get a number greater than 9, you used to take the carry. Similarly, whenever I get the number greater than 3, I will take the carry. Understood? Understood? Okay. Otherwise, the other method could be converting to decimal, then coming back from decimal to 4. Next question. 135 plus 144 is 323. 323. What is the base x? What is the base x? Please give us practice question. Yes, Saurabh sir takes aptitude. Yaar, he is a great educator for aptitude. He has taken for classes on Apr Express. That is his own channel. He is leading that channel. And other than that, on RBR sir's channel, on Creatrix channel, he takes aptitude classes. Now tell me the answer. D. Yes, correct answer is D. See, logically how you will solve this? See, when digits present up to 5, correct? When digits are present up to 5, base will be greater than equal to 6. The base will be greater than equal to 6. So that means only two options, D and C and D. Now suppose if I add this, 5 and 4 will be 9, but it is showing 3. If the base was 12, 9 would be allowed, because if the base is 12, then digits up to 11 are allowed, but it is showing 3. That means answer is D. That is the logical method. What is the conceptual method? X to the power 0, x to the power 1, x to the power 2. So I'll write x square. I am converting it to decimal. Okay. Converting it to decimal. Similarly, x square plus 4x plus 4. Similarly, 3x square plus 2x plus 3. So it will be x square, 2x minus 7x, 3 minus 9, like this. Base cannot be negative, so you can't use x plus 1 equal to 0. You will have to use x minus 6 equal to 0. This is the practical method or the method that is applicable to every problem. The first explanation that I gave was based on options. Okay. Next question. Consider the equation 43 on a base of x is y3 on a base of 8. What is the number of possible solution? Try this. What is the number of possible solution? Solve this by standard method, whatever we know. Come on everyone. Harish, 2 and 3 are not factor because it is minus 6. 2 plus 3 is 5, but 2 into 3 is not minus 6. Okay, Harish? You are confused, my dear. The factors are 6 and 1. Because when I take 6 and minus 1, then the product is minus 6 and the sum is 5. Now, come on, tell me. What will be the answer to this? 4, 3 on a base of x. RBR sir will also take some subjects for you guys. Octal to decimal, Arnab, with using the powers of 8. 8 to the power 0, 8 to the power 1, 8 to the power 2, like this. Now let us see. We will have x to the power 0, x to the power 1, 4x plus 3. So how many solutions are there? Infinite. Okay. X will be greater than equal to 5. Why? Because the digits are up to 4. If the digits are up to 4, the base must be greater than equal to 5. Okay. So x is greater than equal to 5, then you can have any value of x, like 6, then y will be 3. Then if you have 7, then if you have suppose 8, y is equal to 4. If you have 9, but 1 minute, y must be less than equal to 7, not infinite actually. See, just a minute. Y must be less than equal to 7 because the base is 8. So suppose if I take y equal to 7, x will be 14, y equal to 6, x equal to 12, y equal to 5, x equal to 10, y equal to 4, x equal to 8. This is not possible Because x must be greater than equal to 5. So how many combination? 3 and 2, 5. There are totally 5 solutions. Are you getting my point? Are you getting my point? X must be greater than equal to 5 because the digits are up to 4. And y must be less than equal to less than 8 because the base is 8. Okay. Is this clear?